Today we're going to take a look at another interesting example of the sum of geometric progression. Example 10. The sum of the first n terms of a geometric series is 127, and the sum of the reciprocals is 127/64. The first term is 1. Find the number of terms and the common ratio. Solution. When we take a look at the solution, what we have now is that the sum of the first n term, that means that Sn equal to T1 plus T2 plus T3 plus ... plus Tn, and this will equal to 127. This implies that Sn will be equal to A plus AR plus AR squared plus ... plus ARn minus 1, and this will equal to 127. In the second line of the statement, you say that the sum of the reciprocals, reciprocal means 1 over the inverse of them, Sn, 1 over. This will be equal to 1 over T1 plus 1 over T2 plus 1 over T3 plus ... plus 1 over Tn is equal to 127/64. So what this simply means is that this implies that 1 over Sn will be equal to 1 over A plus 1 over AR plus 1 over AR squared plus ... 1 over AR raised to the power of n minus 1, and this will be equal to 127/64. But recall that the formula for Sn is equal to A brackets R raised to the power of n. I don't see the numbers yet. So, but in any case, we're going to use the standard one, the first formula for the sum. And we are told that this will be equal to 127. So what you are going to do here, so this will be that Sn will be equal to A bracket R raised to the power of n minus 1 all over R minus 1. This will be equal to 127. That's the equation 1. And also, for 1 over Sn, we use the formula when R is less than 1, equal to A bracket 1 minus R raised to the power of n all over 1 minus R. This implies that 1 over Sn will be equal to A bracket 1 minus 1 over R raised to the power of n all over 1 minus 1 over R. How do you get 1 over R? Reciprocal. In the first statement, here R is equal to 1, and here R will be equal to 1 over R. Sorry, R is R, while here R is 1 over R. So if you go into 1 and 2, that's from 1, this is equation 2 now. Let's say from 1, A is already 1, so that means from 1, it's a 1 bracket R raised to the power of n minus 1 all over R minus 1 is equal to 127. This implies that R raised to the power of n minus 1 used to be equal to 127 brackets R minus 1. Now, if you go to the second one, from from 2, 1 bracket 1 minus 1 over r raised to the power of n all over 1 minus 1 over r. This will be equal to 127 over 64. So if you take a look at that LCM in the numerator, this implies that r raised to the power of n minus 1 all over r raised to the power of n. Then you divide by r minus 1 all over r. That will be equal to 127 over 64. So when you divide that, you're going to have that r raised to the power of n minus 1 all over r divided by r minus 1 all over r, and this will equal to r raised to the power of n minus 1 all over r raised to the power of n times r over r minus 1 is equal to r bracket r raised to the power of n minus 1 all over r raised to the power of n bracket r minus 1. So, and this will be equal to 127 over 64. Now, if you take from this one, suppose we call this one equation, so we call this one 3, and take this one as equation 4. So, solving 3 and 4, already know that from 3, r raised to the power of n will be equal to 127 bracket r minus 1 plus 1. This will be equal to 127r minus 127 plus 1. And this will be equal to 127r minus 126. That's equation 5. So substitute that into equation 4. Substituting that into equation 4. Substituting into equation 4. What you are going to have is equation 4 says r bracket r raised to the power of n minus 1 all over r raised to the power of n bracket r minus 1 is equal to 127 over 64. So what you are going to have now will be that r bracket 127r minus 126 minus 1 all over 127r minus 126 into r minus 1, and this will equal to 127 over 64. So this also implies that r bracket 127r minus 127 all over 127r minus 126 bracket r minus 1, and this will equal to 127 over 64. So if you go further, you're going to have that factor out 127r bracket r minus 1 all over 127 minus 126 into r minus 1 equal to 127 over 64. So this will cancel this. This implies, and this one will also cancel this one. We have this imply that r all over 127 r minus 126 equal to 1 over 64. So what I'm going to cross multiply, I'm going to add as 127 r minus 126 equal to 64r. So that means that 127r minus 64, R is equal to 126. So if you subtract that now, take a look at this subtraction. You can try it, but let's see what the subtraction gives. 127 minus 64 equal to 63. 63R equal to 126. So R is equal to 2. R is equal to 2. So let's see what should solve it here. Sorry. Let's complete the value here, down here. So from, let's complete it. It says from equation, I use the one that will be easier for us. From equation 5. From equation 5, we have that 127R minus 126 is equal to R raised power of n. That means that R raised power of n will be equal to 127 multiplied by 2 minus 126. So that means that 2 raised to the power of n is equal to, let's do the multiplication now. 127 times 2 minus 126. I'll give you 128. So 2 raised to the power of n is equal to 2 raised to the power of 7. So n will be equal to 7. Therefore, the common ratio, the number of terms is 7. N is equal to 7 and R is equal to 2. So this is where we are going to end the class for now. If you have any question, you can